I'm a great supporter of the concept cell work, and I believe this is a real game changer because for the first time in the human brain, you are recording impulses in cells that are directly linked to behavior, to recognition, to thinking about something, and so on. This is absolutely wonderful. This is the holy grail. This is what Francis Crick was looking for.
For the audience that's not necessarily familiar with concept cells, say a little more about like what they are and why that was a revelation for you about consciousness.
Well, it was always possible that there was such a thing as a concept cell, or the same sort of cell used to be called a grandmother cell or a Gnostic, G-N-O-S-T-I-C, a Gnostic unit. This was the idea that you would have particular cells which would code for a whole lot, that they would code for a person or a place or an object, a car, a fountain pen, and so on. The alternative was that the information was disseminated. It was spread out. Different parts of it were housed in different neurons in different parts of the brain. So you had one part of the brain which was concerned with shape, another one with color, another one with movement, another one with position, and so on. And the finding of concept cells, I think, has really settled that argument. William James talked about principal cells. I think that was his term for them. Principal cells, grandmother cells, concept cells, all the same thing. These cells actually exist, and they were discovered in the human hippocampus, and it was work that was undertaken in the neurosurgical unit in Los Angeles, and it was work which had actually been going on for some time without any great fuss being made of it. It was started by a neurosurgeon called Paul Crandall, and eventually it was taken up by Isaac Fried, F-R-I-E-D, who I believe you've interviewed.
That's right, yeah.
Right, yes. And at one point, Christoph Koch and Rodrigo Quiroga joined in.
Yeah.
And they really developed it, Quiroga especially, because he was a computer scientist, and he was able to design a cell functional isolation program, a spike recognition program, which was better than anything hitherto, so that you could isolate the activities of individual hippocampal neurons and see how they behaved. And these recordings were made in conscious human beings who had fine wire electrodes inserted for good reason, because the idea was that they could record any abnormal epileptic activity going on in the temporal lobe. And one of the first concept cells that the Christoph Koch, Quiroga, Fried team discovered had to do with the film star Jennifer Aniston. And they found that they could record from a cell which would respond to different pictures of Jennifer Aniston. It didn't matter in which direction she was looking or what clothes she was wearing. The cell, as it were, knew that this was Jennifer Aniston. And then there were other cells which respond to buildings or objects and so on, even to equations and shapes. And there were concept cells because it wasn't just the vision, it wasn't just the look of the person or object, it was also the noun describing them. Jennifer Aniston, motor car, so on. It didn't matter whether it was a voice saying it or whether it was a word written down. The cell would respond in the same way. So it was a concept for the person or thing. And this was a huge advance. I'm astonished that more attention hasn't been given to this, because the relationship to consciousness was so obvious. If you asked a person to think about Jennifer Aniston, then the Jennifer Aniston cell would be firing away at the same time. If you showed a whole lot of pictures, only one of which was Jennifer Aniston, the cell would only fire when it was Jennifer Aniston. If you made the exposure time, the picture you actually flashed on the screen, as brief as 100 milliseconds or so, the cell would only fire at the time the subject was able to recognize Jennifer Aniston or whatever it was you were showing. So there's a perfect correlation between conscious awareness and the firing of impulses by a concept cell. As I said, that really is the holy grail of consciousness work. But you can go to a symposium on consciousness, like the one recently held in Sicily. You can look at the program and you can find that there are 200 presentations, and you'll be astonished that not one of those presentations, either in its title or in the suggestion of the title, has anything at all to do with concept cells.
Really?
Even those who are working on memory, not all of them seem to understand the importance of the concept cell foundings.
Interesting.
It's transformational.
Right.
It's absolutely wonderful work. And I feel so envious of the people who did it.
I think I see your connection, but I still feel like we have correlation of the cell firing with the quote unquote conscious recognition of Jennifer Aniston. But can you complete that connection? Why is a concept cell so important for seeing the hippocampus as being connected to quote unquote consciousness?
Well, I mean, if you're conscious of something, there should be cells in your brain which are firing off about that thing, whatever it is. And in the hippocampus, there they are. This is it. And what is remarkable, I think, is that the hippocampus can do this because of the synaptic arrangements within that organ. The fact that you have many more CA1 cells than you have CA3 or CA2 cells, and you probably have many more of those than you have cells for the same thing, the same concept, in the entorhinal cortex. So because of the way the hippocampus is wired, you actually have amplification going on. This brings up other issues, one of which is the signal-to-noise ratio. Anyone who's recorded from a brain, either in an animal or in a human being, which I have done, is astonished or should be astonished by the amount of apparently spontaneous activity going on. The brain is fizzing away with impulses. Now, if you show someone a picture of Jennifer Aniston or a motor car and you only flash it on the screen for 100 milliseconds or so, just long enough for it to be recognized, the brain has a tremendous challenge. You know, it's only had that very brief time. It's got to come up with the answer. Yes, this is Jennifer Aniston. Yes, this is a motor car. Yes, this is a ship. Yes, this is a watch or a book. It's got to do it. And somehow it's got to, as it were, ignore all the background activity going on in the hippocampus. And it does it. It's almost magical. But the way it does it is by not having a handful of neurons coding for the same thing, but it has thousands of neurons for the same memory, whether it's for a person or a thing. Now, you're dealing with thousands of neurons. You're also dealing with cells which are not just going to fire one impulse, but they'll probably fire a burst of impulses, on average half a dozen impulses. So what you've done is you've improved the signal-to-noise ratio in favor of the object that's producing all the activity. And we know from sort of classical neurophysiology that you can improve the signal-to-noise ratio by a technique called averaging, where you give the same stimulus over and over and over again, and you add the responses together. And if there's noise in the system, it will cancel out and it will leave the true response. Well, if you only see something for 100 milliseconds, you can't do that. You're not having your stimulus, your image repeated. It's one go, one very brief go. So instead of averaging over time, you're averaging over space. This is spatial averaging. And I've done the calculations, and using the figures I have, you can improve the signal-to-noise ratio by hundreds to one. So the signal stands out in the background of activity, and only the hippocampus, because of its synaptic connections, can do this.
Thank you, Alan. Take care, and I'll talk to you soon.
That's right. We must keep in touch.